wet noodle, and you just can't control where they're going to go. At the other end of the scale, you have industrial robots, as Geoff talked about. They're precise and they're rigid, and they can be very fast, and they're great for doing stuff on the outside and for automation. But if you want to get inside spaces, or if you want to do stuff that's quite delicate in confined spaces, then they just can't get inside. The elbows get in the way. Snake arm robots are somewhere in between these two areas. They're flexible, like boroscopes, but they're controllable, like industrial robots. We're part of a fuzzy area between industrial robots and service robots. Some of the robots that we make are absolutely industrial robots, but some are definitely described as service robots. But the principle is the same. How they work is there's a stack of links. Wires terminate at the end of a stack of links, and by pulling the wires, using actuators in the base, you can control the angle of the segment and the direction of the bend. By stacking a whole load of segments one on top of the other with all of the motors housed in the base, you can then pull the wires using an awful lot of maths to follow a path into a confined space. In this case, a tank or a vessel. But again, from that picture you can see, if you wanted to use an industrial robot to get in there, the elbows would be far too big. You'd never get in there. This is a robot that we've built for Airbus. This is for getting inside wings and doing assembly tasks inside wing boxes. So you can see the snake-like motion here. You can see why we call them snake arm robots. This robot this has got a swaging tool on the end, but this robot was also for doing sealant application and inspection. This is a demonstrator robot, and we're currently building the next generation, which we'd like to put on a production line in the next few years. This is absolutely an industrial robot type of snake arm, but it's not like a rigid link industrial robot. So there are lots of differences in industrial robots. Some other work we've done in the nuclear industry. This is some work that we did with a nuclear power station in Sweden. This is a robot which was manipulating tools and fixtures amongst a whole load of pipework. I won't go into details of this project, but effectively there was a pipe in an awkward place beneath a whole load of pipework, and you couldn't get to this pipework, and it had to be replaced. Otherwise, the nuclear reactor would have to be shut down. So we built two robots which could access the site and replace the pipe. And it was very successful. The customer was very happy. And lastly, I'll quickly mention our work in the security industry. This is a robot that we built with UK MOD a couple of years ago. This is 2 meters long, and it's a real beast of a snake arm robot. So it's for looking inside, inspecting inside cars, and just accessing areas where current bomb disposal robots can't get to. This robot is for the US Department of Defense. This robot is at completely the other end of the scale. This is almost an endoscope, really. It's 1/2 inch in diameter, and it's almost life-size there, really. It coils up inside a briefcase-sized box. It's fully portable, and with the joystick you can control the tip to wiggle out and inside a box or a suspicious package. I don't know what it will be used for. They don't tell us. So, are there any questions? Had to go through it all quite quickly, but yes.
I was quite interested in seeing whether the arms and snakes into the aircraft wing section. Are you talking to the guys at Bristol about their self-healing composites, which will also give an indicator of any sort of cracks, etc. for them? I'm just thinking of a fluorescent dye in there.
We're not at the moment, so I might go talk to them later.
It would be quite interesting.
Have you just come from that presentation? Yeah, go and talk to them.
Can I ask what are the next major challenges in robotics?
Sally?
There's two things. I mean, you've got the building up of a robotics industry, which is companies like mine and like Robotics, which are working on really pulling the market up, because the market is way below what we can actually deliver. But if you say what are the technological challenges, then it's all about intelligent devices and actually making them work robustly. If you're going to get a robot into the home, it's got to actually interact with people. It's got to understand people. It's got to be intuitive to people. There are a hell of a lot of challenges in actually doing all of that.
Do you think you've oversold robotics in some ways? Because, if you think of, going back to Robbie, the robot in Help Me With the Film.
Forbidden Planet.
Forbidden Planet. We've created the idea that, robots can do all these sorts of things, but whereas if you've ever bought a vacuum cleaner that was a robot, they're hopeless.
Yes.
Hopeless.
But
you might as well do it yourself. But you've kind of created the robotics' image in some ways is actually counterproductive to its sales because people expect more of it than it can.
Some people do, and I entirely agree with you. Although the vacuum cleaner, the only thing that's wrong with that is actually the vacuuming bit. It actually does the navigating bit fine. But no, that's because
navigating device thing.
Yes, I know, but that's because there's a lot of technology pushing robotics that's wrong at the minute. It's not actually application-led, and that is a big problem. The other thing is the domestic market is being pushed too quickly at the minute. We can't deliver the functionality at the cost.